Hello everyone, I am Yi-Chiao from Nagoya University, Japan. Today I would like to introduce our cooperative work with Academia Sinica Taiwan, the relation data selection for data augmentation of speaker-dependent multi-band MelGAN vocoder. This is my outline. I will first introduce the basic idea of neural vocoder, and then the proposed data selection criteria. Both objective and subjective evaluation will be presented. In the end, I will give discussions and conclusions. A vocoder is a voice coder, which analyzes speech waveform into acoustic features, such as spectra and perceptive features, and synthesizes speech waveform based on the acoustic features. However, a neural vocoder focuses on only the synthesis process. A neural vocoder is a neural speech generative model, such as WaveName. The input can be acoustic or linguistic features, and the output is a speech waveform. An universal neural vocoder is for arbitrary speakers and trained with a huge multi-speaker corpus. If the amount and diversity of the trained corpus are sufficient, the universal vocoder can achieve high-fidelity speech generation. However, the speaker similarity of the generated speech usually degrades when the speakers of the input features is unseen. That is, the generated speech sounds like natural speech, but doesn't sound like the target speaker. Because of the huge trained data requirement and the degraded unseen speaker similarity problems, a more economical way is using a speaker-dependent SD vocoders. Specifically, train a speaker-independent SI vocoder using a large multi-speaker corpus first. Then adapting the SI vocoder to a speaker-dependent SD vocoder using limited target speaker data. Generally speaking, 5-minute data is sufficient for the speaker adaptation. However, in this paper, we tackle a more challenging scenario that only 30 seconds target data is available. A possible solution is to select suitable data from an easy access external multi-speaker corpus for the target speaker adaptation. And the selected data should have the similar speaker characteristic to the target speaker. Therefore, we proposed relational data selection, RDS, to select the adaptation data based on data relationships. The proposed RDS is a hierarchical framework, taking 3 levels of data relationship into account. The first level is speaker similarity to consider the similarity between candidate and target speakers. The second level is the speaker-wise competence to consider the inter-candidate speaker relationships. The third level is the utterance-wise competence to consider the relationship among the utterance within a candidate speaker. To measure the speaker similarity, the proposed RDS adopt X vector for speaker representation and PLDA for similarity measurement. Moreover, sigmoid temperature is applied to make all score positive for the fuel regularization. Since a robust speaker representation should be almost content independent, the X vector from the same speaker should be similar. Therefore, we propose a speaker-wise divergence regularization term, sigma n, to penalize the candidate speaker with diverse X vectors. To tackle the outlier utterance within each candidate speaker, we propose an utterance-wise divergence regularization to penalize the utterance has a very different X vector from the X vectors of the other utterance within the same speaker n. Multi-band MelGAN is adopted as the testing neural vocoder in this paper. Corpus used in ICAS 2021 and 2 VOC challenge is adopted for model training and testing. For reference, including natural ground truth, speaker-independent SI baseline, upper bound adaptive 90, and lower bound adaptive 5, and 3 proposed systems, DC1, DC2, and DC3 were evaluated. 6 objective measurements were adopted. Log spectral distance and male capture distortion, major spectra modeling accuracy. IMSE of log F0 and onboard sport decision error measure pitch modeling accuracy. PLDA and cosine similarity measure speaker similarity. The upper bound adaptive 90 achieved the best performance in all metrics, which show the effectiveness of speak adaptation when the adaptation data is relatively sufficient. However, the result of the lower bound adaptive 5 show that the insufficient adaptation data cause significant degradation in all metrics. Compared to the baseline SI and the lower bound adaptive 5 systems, the proposed DC1 to DC3 systems improves the performance in most objective metrics. For the subjective evaluation, the similarity and quality MOS tests were conducted. Natural utterance achieved almost 5 out of 5. However, the speaker mismatch caused significant quality degradation of the SI vocoder. After speaker adaptation with 8-minute target speaker data, both quality and similarity are significantly improved. However, if the speaker adaptation data is only 30 seconds, both quality and similarity are further degraded. On the other hand, with the proposed data augmentation, both quality and similarity are improved. Compared to the baseline SI vocoder, the proposed method improves the speaker similarity while keeping the similar quality. Furthermore, we plot the gender-wise PLDA score distribution for the female speaker and the first male speaker. The results show that the PLDA score reflects the high correlation between gender and speaker similarity. The result also show that optimize the selection number of the utterance is changed because of the rapid PLDA score decrease for the increased selected utterance. To further explore the effectiveness of the proposed regularizers, we report the statistic of the selection utterance for the female target using DC1 to DC3, and DC1 is taken as the reference. The number of speakers means how many speakers do this sentence come from. An utterance might be an outlier if it is the only utterance from a speaker to be selected, and we call it a suspected utterance. The speaker-wise regularizer is adapted to filter the utterance of low-confidence speakers, and the speaker number of the selected utterance does decrease in DC2. The low speaker overlap rate between DC1 and DC2 also shows that the speaker regularizer filters many speakers. The utterance-wise regularizer is adapted to filter the outlier utterance, and the suspected utterance number does reduce in DC3. The higher speaker but lower utterance overlap rate between DC1 and DC3 show that the utterance regularizer make DC3 select more representative utterance of each speaker, and the influence of the speaker regularizer is eased in DC3. In conclusion, the influence of speak adaptation and adaptive data vary on the effectiveness of speaker-dependent neural vocoder are investigated. The proposed selection criteria explore the different relationship in the data space to leverage an external corpus for improving speaker adaptation. The evaluation results show the effectiveness of the proposed framework in speech synthesis with limited target data. More details can be found on our demo page and our paper. Thanks for your attention.